today we're going to talk about higher degree polynomials. So the first thing that you should know, Champ, not today, I got it. Today we're going to talk about higher degree polynomials. In this example, you might be familiar with y equals x squared. That's twice. Let me get it right the third time. And in this graph, if you look at a y equals x squared graph, and they have all these examples here, the one that they're trying to use is this one right here. And what I want you to notice is what happens when that power increases. So the second one is y equals x to the fourth. That would be this one. And then the last one is y equals x to the, looks like 8 to me. And the question is, what's going on as the power gets bigger? And what I want you to notice is that as the power gets bigger, or the exponent, the base gets wider between -1 and 1 for x. And then also, what you should be noticing is when x is less than -1 or x is bigger than +1, it's steeper. Meaning that the rate is a lot faster. Sometimes in the past, I've said big power, big butt. Because it's wide on the bottom. And for some reason that seems to stick with people. Joe Green, that was for you.
Big butt. Big power.
No, Joe. Not big butt, big power. Big power, big butt.
Big power, big butt.
Yeah.
It's not any good.
There's a difference. All right, likewise, if you work with odd powers, it's the same. So if I look at y equals x cubed, which is the general, I'm not going to use these graphs, but it's the general x cubed graph, looks like this. And then I go and I look at something that gets a little bit bigger in the power, like x5. Then what happens with an x5 is that the bottom gets wider. The bottom gets wider and then goes steeper. Same kind of thing. No, that's not what I wanted. Forget it. I'm just going to use this. Okay, so here's x cubed. Here's x5. I'm trying to distinguish so you can see the difference. And then here is x7. And I'm drastically changing the graph. This is not very good drawing as far as curvature goes, but it's trying to show you the same thing. Same idea. Just like the even powers, in between -1 and 1, when the power increases, it widens out. That's because you're taking a decimal or a fraction like 1/2 and squaring it, which means when you square a half, you get a quarter, very small amount. Whereas when you get past 1, so let's say we're talking about 10, and I take 10 and square it, that's 100, but if I cube it, or sorry, if I raise it to the 4th power, now I'm talking about move the decimal 4 places. So now you're at 10,000. So it's a lot steeper outside of the ones, either end, and a lot wider on the bottom in between the ones. Just so you know how to recognize the difference. So it'll be like a matching. They're not going to tell you what they are, and they're going to say, which one is this? X squared, X4, X8. And you can kind of tell by how wide it is on the bottom and how steep it is on the ends when you compare. That's the big idea. Okay, next one. We're just going to sketch some graphs. Remember, there are some key points oftentimes that you can do with this. This is not a completing the square activity or anything like that. By the way, our assembly starts at today because we have Pep Fest on the desk. It starts at 9:43, so we're out here at 9:43, and then we'll be coming back at 10:39. So 9:43. So we have until then to try and get done with this thing. As I sketch this thing, I look at a couple things. Number one, bless you, I see a fourth power. So this thing looks like a parabola, but it's got a big butt.
Oh.
How do I know it's got a big butt?
Big power,
Big power. So it's wide. And then the negative sign tells me
upside down.
upside down. Okay, so I should be thinking about that. Oh, and the plus 2 inside tells me
Left 2.
left 2. So all these things I'm thinking about. I know it's an upside down parabola, move to the left 2, and it's got a big butt. So if I was doing a quick sketch, which is maybe not going to be an accurate sketch, and I know I'm at negative 2, 1, 2, I probably should find out, oh, if I'm at negative 2, then it opens down, because there's nothing else going on. So here's my vertex at negative 2, and I know it's got a big butt and it opens down. So maybe something like that. So that's a sketch. What do I know? I know that my vertex is at negative 2, 0, which is also my x-intercept, by the way. If I was looking for my y-intercept, I would put in a 0 for x. So 0 plus 2 is 2. 2 to the 4th power is 16. Take the opposite, negative 16. So this location right here, which I did not put a scale on, is at 0, negative 16. Done. Next. This one is a 5th power, which looks like a cube, the S graph. And it's moved to the right 3 and up 4. Joe.
So did you knew it was the 5th because it was the odd number? It was a large odd number exponent?
Yes.
Because the third to the third means
1, 2, 3, 1, 2, 3, 4. Here is my new centering point. So it looks like this, but it's got a big butt, so it's kind of wide. I have no idea if this graph is correct. Looks something like that.
So it's to the 7th power also like that?
Yes. So this is 3, 4, this location right here of this point. That's a critical value that you should probably know. So if I put down critical value of 3, 4, that's something interesting that's happening there. And then, I don't know, but I'm going to check to see if it has a y-intercept. Because I like those because I think they're kind of easy to find. So if I look for my y-intercept, that means I'm putting in a 0 for the x value. So I go over here and I put in a 0.
Negative 3 to the 5th power.
Negative 3 to the 5th power. That sounds right. Negative 243 plus 4, negative 239. This graph is crap. Like that should have been like down here somewhere. So this is supposed to be 0, negative 239. That's the y-intercept. And then, if I look for the x-intercept, which sometimes is a little more challenging, that means when the y value is 0. So in order to figure that out, I shove a 0 in for the y. So in our equation back up here, if I do that, that means I have 0 equals x minus 3 to the 5th power plus 4. Move the 4 over. I get negative 4 equals x minus 3 to the 5th. How do I get rid of a 5th power? 1/5 on a calculator, or the 5th root. So I need to take the 5th root of this side and the 5th root of this side. Oh, I 5th root of a negative number. No.
No.
Imaginary.
There's no uh-oh. Odd powers have no issues. So you don't have to worry about anything.
Oh.
Ah. Oh.
Ah.
Don't be a nerd. So it's the 5th root of negative 4 is x minus 3. So if you want to figure out your intercept, you move the 3 to the other side, and the answer is 3 plus the 5th root of negative 4, comma 0. I don't even know what that is. I have no idea. Something around 3. Because the 5th root of negative 4 is something really small negative. But that's the exact answer. If you had a calculator, obviously you can just do the second trace 5, enter, enter, arrow, enter, and find the number. No big deal. But I like to show algebraically because most people, that's where we mostly need a little assistance. And in number 3, it says, describe the right hand and left hand behavior. So that means, am I going, when I'm looking at the left side, am I way up here going on forever, way down here going on forever, and likewise on the right? And what I'll tell you is, you already know this stuff. So look at letter A in 3. What's the biggest power?
4.
So I look at this term. It says negative x4. Which way is it opening?
Down.
Down. That means that my parabola looks like this. Because 4th degree is like a parabola, just a bigger butt. And it's opening down. Now, let's go back up and let me just show you this. This is the stuff that they're talking about. First of all, n, which is the power that they're talking about. So this n thing, n, is the power. So in our case down here that we just did, the power was even. Yes?
Yeah.
And I know that the number that was in front of that term was negative. That means the A was negative. So this is the number in front. And so if the power is even, and the number in front of it is negative, it's opening down. Oh, look, here it is. It's upside down parabola. Right? That's what they're talking about. So when you see stuff like this, it helps to think about numbers. In part B, I look at the biggest power. The biggest power happens to be is that a 5?
Yeah.
So 5x5. I know that this thing looks like this. The right side is going up forever. The left side is going down forever. Where is that one? Right here. Because the n power was odd. That was a 5 in that case. And it was positive. And that's why we picked this one. Positive number in front, odd power. So when they talk about the n behavior, they don't do the little squiggly in between. They're just talking about right and left, what's going on. That's what they mean. If you draw the little picture for me when they ask that question, good enough. It's even better. Mumbo jumbo, mumbo jumbo, mumbo jumbo. Next. Okay, so first of all, I'm going to show you the short, not so